Okay, good morning. This is Tom from Powerside, and I would like to continue with a short video on the IPC, focusing on the best practices and potential pitfalls when it comes to setting up the IPC. And this video will focus on the rear of the IPC. Please make sure that you look at the operations manual for all of the features that we have, including the comms, the remote capabilities, and the analogs. We will not be addressing that in this video, but really going through some basic steps when it comes to testing. Now, first thing I would say is when you set up the IPC for testing with your equipment under test, obviously you need to ensure instrument power and connect the IPC to a power source so that the IPC then is in the on condition. The other thing you need to do is to connect a laptop to the IPC and make sure that the relays are in the correct state. And we can also, once the unit is up and running, we can use the IPC effectively as a voltmeter. So what we do is, again, I will produce a number of videos, but it's important on the front channels that you set the source and load voltage because we are going to, when we connect the IPC, we're going to have to verify that the voltages that you're connected to on the source side do match what we see on the instrumentation at the front of the IPC. In terms of one other precaution that I would bring to your attention, again, this is adjusted on the front of the IPC, but we would really recommend that you set a circuit breaker limit in advance. If not, if the IPC circuit breaker trips, that is going to be a first indication of overload or a first indication that you are creeping up on the limits of the IPC. So I would suggest that you adjust the value reasonably to avoid the tripping of the tool, but set the circuit breaker load on the front of the tool prior to starting the operational test. Now, setting the testing station as well, one other tip that I would give is you should set up the software when the tool is off before you've done all of the connections. And the software, the point of this would be to have the software set up so that the test environment is all set, you understand what you're intending to measure in a calm state before either a tool is running or the IPC is fully connected to the load. In terms of best practice, you would create a unique folder for the test job that you're about to execute to avoid overwriting old data or reusing files or overwriting files, and download every event on all of the channels. Make sure though that the IPC breaker here in the center is off before making any connections. You want this IPC because ultimately what we're going to come to is we're going to connect to the power source of your facility because this is a series type industrial power corrupter. So we're going to connect to the source side. We don't want to immediately connect to your equipment under test. So make sure this breaker is in the off position. Okay, so the next steps I would like to talk about are the electrical connections. Now, it's very important when connecting to an IPC. This IPC is capable of a significant load, so 200 amps, 480 volts, and we must ensure that a certified electrician is in position to ensure the proper connections, the proper safety, and the proper lockout and tagout regulations are followed. In terms of connections, the electrician should know anything that is coming from the upstream source and connected to the source before making any connections. They should understand what type of system. Is it a three-phase delta? Is it Y? The earth, and they should understand the panels upstream that are going to isolate. We need to make sure also that before any connections are made, that that you've verified that the power is off and that you follow appropriate lotto procedures. And not only should you just take word for the breaker being closed, but you must use a voltmeter to verify state as well. So ensure that there's a multimeter, ensure before starting connections that you have properly validated not only lotto, not only followed your own safety procedures, but ensure that the state is well known and is verified through a voltmeter. Earth connections. Earth connections are extremely important. If we look at the IPC connection on the source side, which is this to the left, this is the source block. It's important from a safety perspective to ensure that the earth connection is always the first to connect, and when disconnecting, it's the last to disconnect. This is, again, just good practice, and your electrician should certainly be in line with that. We should show on also on the panel on the front at the point of energization that the state is verified, and that you also have a second method of verifying your voltmeter, which could be indeed the panels on the front of the IPC. So again, ensure lotto, ensure that the source side connections are made. Do not energize until we follow the next few steps. If we then look at the other side of the IPC, we're then at the load side connections. And again, it would be recommended that you would first connect the earth, and then the earth connections would be the last to be disconnected when you stop the test and break down the unit. One thing that I would like to point out is the connection torquing process. If you look at the operation manual, we have torque specifications, but I think simply one area where we would recommend caution and we would want you to focus on is in making the source or load connections and using the torque tool to nip down on whether it's stranded or solid cable, use a progressive method to ensure that you get clean entry of the cable and proper insulation up to the connection point. The other is gently nip down on the cable, ensure that you have proper contact. Then perhaps while the power is off, manipulate the cable to ensure that you've got settling, and then go at it again. Do not just heavily torque large cables without proper precaution, because the connectors can be stripped if they're not handled properly, and that unfortunately would involve returning the unit for repair, which we want to avoid at all costs. So torquing, if in doubt, follow the specs, but I think as a general process, slowly creep up on nipping down the cables. Make sure that there are no strands between, obviously, the terminals. Follow good practice, and just ensure that there's a proper and tight friction connection into these appropriate three-phase neutral and earth connections. So moving forward, we do also have terminal block reducers for smaller wires. Those come in the IPC kit. So again, if you're using small connectors, use the reducers. It will ensure better connection. It will ensure a more secure wiring system, and follow those guidelines when it comes to connecting the IPC, both on the source side, which once again is on this left side, and on the load side, which is where the proper phase cables, and ensure that they are properly identified, they go out to the equipment under test. Now, Before you energize any of the sources, in other words, before you close this breaker, you need to have an EMO in place. You need to have, it needs to be compatible with the interface with the EMO circuit before you energize. If they're separate EMO buttons, see the manual. Again, go back to the operations manual, but we must have a proper procedure in place that once you energize, if there is an issue, that you have in advance a process, a safety process in which to follow. Now, once we're all connected at the back, once we've validated the state of the source at the back of the IPC and at the front of the IPC, we would be ready to energize the source, remove the LODO, and first step would be to power the source side. In doing so and in powering the source side, again, please follow your local requirements for safety PPE while doing it. The breaker of the IPC must be off, but when you energize, make sure, whether it's NFPA 70E or other standards, make sure that your electrician is following the appropriate safety guidelines, because there is potentially a high amount of energy coming through this piece of equipment. And electricians, of course, should know LODO, and they should understand the successive energization of the sources. Double check in the front channels. There are adjustable channels in the front, which we can go through in an additional video, but verify that the front channels do read the source volts, and use a voltmeter at the back once you have energized to verify that what you see in the front metering of the IPC, what you see with a multimeter at the rear of the IPC, and what you know as your system all coordinate or all show appropriate values. Once we have done so, then the multimeter effectively reference is validated by the IPC numbers as giving reasonable data. That confirms the source reading, and on the load side, we confirm also that the circuit breaker is open. This also can be used as a process to demonstrate that the connections are correct and the source is appropriate without load. The neutral to earth effectively you can confirm is 0. We can show a video and a subsequent video, and then we're ready to turn on the load when the circuit when the circuit breaker is then closed. Okay, so for the next step, let's talk about turning on the IPC breaker to energize the load. So your source is validated, you validated with a multimeter, your instrument power is on, you can read on the appropriate dials, you've set your circuit breaker rating in the front. Now it's time to allow power to pass through from the source side of the IPC to your equipment under test. Understanding that you've properly validated the connections on the load side. When we're ready to engage the IPC and close the breaker, again, standing at the side of the IPC, the process would be to engage the circuit breaker at the center back of the IPC, and this will then drive load through to the load side of our equipment under test. And again, we are then in a position to validate those loads and those phases and voltages again on the front of the IPC, where we would check that the load is energized. We could check that the load side with a multimeter is seeing the output voltages that we expect at the phase, and then we can confirm also the current draw at the front of the IPC that you're expecting the tool to draw while the tool is in operation. We would check the permanent earth current meter to make sure that there's no excessive current being drawn. We would start with a safety test for the tool. We would go into the mode of testing. I think that would complete what we do at the back of the IPC, and we would then start a number of very gentle successive sags to validate the current draw and the behavior of the equipment under test. So with that, I think we'll pause this video. It gives an idea of the focus on the rear of the IPC, focus on the source, the load side, the precautions to take when connecting, the precautions in terms of LODO and PPE, and the stages prior to closing the breaker and allowing power to flow from the source side to a validated load side, the load side being, of course, your equipment under test. There's no substitute for the operation manual. This has a lot more detail, a lot more explanation, but I hope this video has been useful, and I hope it gives you some tips for very successful testing using our industrial power corrupter. Thank you.